Hello children, welcome back to physics class. In today's class, let us discuss in detail regarding the factors affecting magnetic induction and the detailed study on bar magnet. So, here we begin with the first one is all about the factors affecting magnetic induction. First one, suppose if you are trying to magnetize a given magnetic substance, then the stronger magnet will in turn produces a powerful magnet, whereas a weaker magnet induces a weaker magnetic field. I repeat, whenever we are trying to manufacture an artificial bar magnet, then a stronger magnet induces more powerful magnetism, whereas a weaker magnet induces a feeble magnetism. And one more thing you need to understand that the first one is that stronger magnet induces or produces more powerful magnet. And vice versa. Next one. In the previous class, as we have discussed that with the help of a stand, whenever a steel bar or a iron rod is attached to a stand below which a ball of iron filings are being kept, and whenever a bar magnet is brought nearer to that, magnetism is induced in the given material, and as a result the iron filings get attracted to this bar. Why? Because magnetic field is induced. And remember that the amount of magnetic field induced is always inversely proportional to the distance between the magnet as well as the magnetic material. Suppose the distance between them is r. This bar magnet and steel bar, if it is very far away, very less number of iron fillings will get attached. Whenever the distance of approach is reduced, as and when the bar magnet is approaching this magnetic material, then more number of iron fillings gets attached. So, from this we can conclude that the magnetic field induction is inversely proportional to the distance between the magnet as well as that magnetic material. So, larger the distance, less magnetic field is induced. Lesser the distance, large magnetic field is being induced. And one more thing you need to know, children. The third point is all about the retentivity. Suppose if you consider two materials, one is iron, the other is steel. For iron, the retentivity is low, whereas for steel, the retentivity is high. So, what do you mean by retentivity? Retentivity means the time during which it possesses that magnetic property. Suppose if magnetic field is induced in iron as well as magnetic field is induced in steel. In order to make this iron, a piece of iron to get magnetized, we require less effort. Okay. So, we require less effort. That means the iron can easily get magnetized. The piece of iron can easily get magnetized. But how long that magnetic property lies inside the iron is very less. That means it is easy to get magnetized and at the same time it loses its magnetic property sooner. But whereas if you compare this piece of iron with steel, it is a bit difficult for a steel piece to get magnetized. It takes large amount of effort and large amount of time to get the steel to get magnetized. But the retentivity in this steel is higher. That means when the magnetic property whatever is being induced in the steel, it will stay for longer time. The magnetic property in the steel stays for longer time, whereas iron it loses very fast. The reason why retentivity means retention of that magnetic property, storage of that magnetic property. So very easily it loses very fast, very sooner. But here in steel it lasts for longer time. I hope you understand, children, all the regarding how the factors that affect the magnetic induction. In the next topic, I would like to describe you in detail regarding what exactly a magnet consists of, that is bar magnet. So here we continue with the bar magnet. So as I have already discussed, children, let us consider a bar magnet as a piece something like this. Let us consider a bar magnet. No doubt, for every bar magnet consists of two poles, one is north pole and the other is south pole. So before introducing this, first of all, let us see, if you consider a piece of bar magnet, then if you, with the help of a scale, if you start measuring its length, the length that begins from here, the one end of the bar magnet to the other end of the bar magnet itself is called as the geometric length of the bar magnet. So what is L, children? L indicates the geometric length of the bar magnet. So with the help of scale, whatever the length you measure, that total length from one end to the other end gives the geometric length of the bar magnet. But whenever you take the piece of bar magnet near some iron fillings, then what you observe means most of the iron fillings get attached at the two ends, something like this. Okay. So leaving a little space at the ends, more fillings are attached at these two particular positions, children. At those two particular positions, more iron fillings get attached as compared to the other parts of the bar magnet. See, at this end very few are being attached, here also very few are being attached. But at these particular 2 points, large number of iron fillings got attached to the bar magnet. So with this we can conclude that, and we name this as a north pole and here as a south pole. So the place where more iron fillings get attached are called as poles of the bar magnet. So one pole is named as your north pole, the other pole is named as your south pole. So how this north pole and south pole is named means, first of all you have to suspend a freely suspended bar magnet. You have to consider it always points towards the north-south direction of the earth, and hence the name was given as north pole and south pole. Okay. And from the north pole to this south pole, some length you can measure, and that particular length is called as your effective length of the bar magnet. So that is generally indicated with the letter 2L, and this 2L is nothing but your effective length of the bar magnet. With the help of scale, whatever you measure geometrically, that gives the geometrical length of a bar magnet, whereas the distance from one pole to the other pole gives the effective length of the bar magnet. I hope you understood this concept, children. Well, apart from that, there are few more things you need to know about this bar magnet. So how many poles does a bar magnet really have? Yes, that's true. It must be having two poles, and one is named as a north pole, the other is named as your south pole. For the same bar magnet, if you go with the detailed study, the line that passes along the bar magnet, passing through both the poles, that is north pole and south pole. This line itself is called as your axial line. So, what is this line called as, children? Axial line. Okay, the line that passes along the bar magnet through the north pole and south pole, that line is called as your axial line. Whereas the other line which passes from the midpoint of the bar magnet and perpendicular to the axis of the bar magnet is called as your equatorial line. This is called as your equatorial line and this is called as your axial line. Okay. One more name is also called as, instead of equatorial line, few people can say it as magnetic equator. Magnetic equator. So, this is only about the line I am telling. Only line is equatorial line or axial line. But if you consider a plane, so the plane, so children, line is different, plane is different. If you consider the plane that passes through the magnetic field, the complete plane that passes through the magnetic field, that plane is called as your magnetic meridian. Okay, children. So, what is this called as your? So, a plane like structure, that passes through the axial line of a bar magnet, the complete bar magnet, that plane itself is called as a magnetic meridian. Similarly, the other plane which passes along the equatorial line of the bar magnet, complete plane that passes along the equatorial line of a bar magnet, that is called as an equatorial meridian. So, what is this called, children? Plane, if you talk about a plane, that is called as a meridian. Along the equator, equatorial meridian. The line means equatorial line. Along the axis, axial line and magnetic meridian. One more thing you need to know, children. For every pole, it possesses some strength of attraction or repulsion. Every pole possesses some magnetic power. And that is called as a pole strength, indicated with the letter small m. So, what is a small m? Small m indicates the pole strength of a bar magnet. And as I said earlier, that is 2L. What is 2L? 2L indicates the magnetic length, effective length of a bar magnet, or simply magnetic length, actual length. Okay. So, if 2L indicates the magnetic length and M indicates the pole strength, the product of pole strength and the magnetic length gives you magnetic moment. So, what is this M indicates? M means magnetic moment. So, this magnetic moment is defined as the product of pole strength, strength of each pole multiplied by the magnetic length. Remember, children, magnetic length is different and geometrical length is different. Geometrical length means whatever the scaling measurement, whatever you get with the help of a scale, that is called a geometrical length, whereas magnetic length or effective length is nothing but the length from pole to pole itself is called as a magnetic length. So, I hope you got the clear view regarding what exactly lies behind this bar magnet. Okay. So, keep practicing, children. Until then, we will meet in the next video with a few more concepts regarding the magnetism. Until then, take care. Have a good day. Thank you.